good morning to our fourth ESSVE presentation, ESSVE academic presentation. It's honest for us that you will be with us for the fourth time in this presentation. This time we will talk about this time of presentation. We'll talk about again the Eurocode and about the axial load, part 2. Part 3 was we talked about the last presentation. If you miss it, you can just go in ESSVE and see the presentation we have already recorded. This is the fourth presentation, and again, the agenda for today is some intro, 3 to 5 minutes, and then we leave the presentation to our dear Professor Eero to talk about the theory behind the axial load, part 2. That after Eero will start to talk about ESSVE and how you implementation the Eurocode with ESSVE, and after that we will open to feedback and questions. But before all this, we're starting with agenda. We want to congratulation Eero. Is his birthday. Congratulations, Eero. Is 25 years, maybe something like that.
It is good. Yes, thank you.
Okay, congratulations. I think before we start with the agenda, I want to pull up one question to see how many has been with us before. Please, I don't know if you see the poll question. You see it? Okay.
Yes, it's released.
You have released it. And if we see the answer is the
I see at the moment clear. 14 response, where 14% is first time, 25 is been once before, and 63% have been more than one time here. So either one, all of the time.
It's very clear that we have more than half of the participated with us for the second or for the third time. It's very great for us to hear about it. Just very quickly, for whom was with us before, that ESSVE, if you don't know about that, we are a leading fastenings company in all the Nordic, and is founded in Sweden from 1970. We have almost 200 employers, and we just to imagine how big is ESSVE is it. We sell almost 5 million screw for one day. And we have 4 application parts. We have foundation and structure. We have building part. We have interior finishing and outdoor carpet. But as you engineer working with the foundation structure, this will be the main part you working with daily. And I think to leave the presentation to my colleague Eero. The screen is yours, Eero, please.
Thank you.
Okay.
I tried to share my screen. I hope you can see that.
Yes, we see it.
Okay, hello everyone. For those who are new here, I'm Eero Tuhkanen from Tallinas University of Technology, and we have this nice academy together with ESSVE, where I present some small parts from new coming Eurocode 5. And we do that in very short way, so the one presentation is only 10 minutes to not overwhelm you, but to give some idea what is going on or what is coming. And today's presentation is the follow-up of the previous one. It's about actually loaded fasteners. Last time we spoke about pull-out strength, but today's topic is design axial compressive resistance. Axially compressed fasteners or screws are mainly used in two situations. One is here on the left side, where the secondary beam is connected to the main beam, and if we do this well-known cross connection or cross connection with the crossed screws, that means the one screw is compressed in this situation. And here is one picture from the test series made by Professor Blas, where we can see this compressed screw buckled in the timber. And the second well-known usage of the screw as a reinforcement, where we have, let's say, under the support, we have not enough strength perpendicular to the crane, so we can reinforce the area to increase the support area, and here the screws are also compressed, and also the buckling is possible in this situation. This buckling occurs in the area about 5 to 10 centimeters from the load application point. So like here in the very close to this connection area. And this calculation method is already used in European technical approvals, so-called ETAs, but now it is also presented in Eurocode. And in Eurocode, the formula or the model we have to check is that we have to find the minimum value from the timber part and minimum value from the steel part. So the timber part, this is what we spoke last time, is the characteristic withdrawal resistance. It's the same as we pull out the screw. It doesn't matter if you push it in or pull it out. The calculation is the same as we saw last time. And of course, design value is covered with partial safety factor and K modification factor. But for compressed fasteners, we have to also check the steel part, which is axial compressive resistance. And the axial compressive resistance is covered with partial safety factor for steel. And today's topic is this FCK, characteristic value for compressive load or compressive resistance. Compressive resistance is actually characteristic yield resistance of the fastener, which is depends on the geometry of the fastener, and also characteristic yield strength of the fastener. This is a material parameter, and in new Eurocode you can find these material parameters in the table, so you don't have to go out to find that. steel values. But that's not all. This characteristic yield resistance of the fastener must be multiplied by a buckling factor, and the buckling factor is usually decisive, and the buckling factor is calculated according to this line of formulas, and I do not go very deep into these formulas, but who are familiar with steel structures or Euro 3, you can recognize the same logic for buckling calculation as we use in the steel. But the only thing is that this buckling in this fastener or in this screw is not free. It means that it's supported by the timber around the screw, and this is considered with the characteristic foundation modulus of the fastener. It's CH, and it depends on the characteristic density of the timber. So this buckling is prevented by timber, and then we have to check how much density do we have to find this buckling factor. The beneficial scenario for this, let's say, the pull-out resistance we talked about last time, and the compressive resistance we have topic today. So one very good example where to use these screws is so-called tapered beam, where we have a glulam beam with inclined top part, and in this kind of beam we have problems usually in the middle zone, where we have tensile forces perpendicular to the grain, and we can reinforce that with the screws. So here we can calculate the pull-out strength of the screw, and also usually the problematic thing is the embedment or the compression perpendicular to the grain in the support area, and here we can use the screws as a reinforcement for this area. But coming back to the last week presentation, where we talked about this pull-out strength of the screw, or let's say push in strength of the screw, it was depending on the factor K mat, which is a material factor which considers the different layers in the structure, and we can use the benefit in such structures where we can, depending on the amount of the layers the screw is penetrating, we can increase this value for pull-out strength or push-in strength. So this was the topic today. Next time we speak about all from the steel connectors, a little bit insight of that. So thank you from my side, and I give the stage to Enno.
Thank you again, Eero, for your presentation. And now I'm leaving the screen to Enno to talk about ESSVE.
Hello, everyone, from my side. During my presentation time, I have also two polls to raise. One poll, I will raise it now. It's related with question, have you used ESSVE before? How long you have been using it? And that's a multiple opportunities also to answer that. Maybe use some other tools as well, because in the end of my presentation, I will ask what will be the other models you are interested to have for ESSVE tools or software. So until you will work on that poll result, I will go forward and who are first time making a smart introduction about myself. Just saying that my part today is to introduce ESSVE as ESSVE timber calculation program. I'm technical sales engineer in a team ESSVE group, and I have in the Baltic states experience about fasteners over 25 years. Today we have it in our calculation model two applications. One is axial, another one is lateral. Today's subject of our calculation is axial calculation. And if you will go on our website, local country, either one Latvia, Lithuania or Estonia, then you can switch here easily the language. And the view is similar, but if you go here under the timber, today I show Estonian side, you will find wood and another one was a concrete. Roll it down, you will find here the ESSVE software. If you go, you will find a little bit lower on catalog for timber tech product range. And here is the area where you could also register it over our website and will see the history of our presentations. That's a small intro on that side. If you go and log it in, who was first time, I recommend you to sign up with your all initials. Then those gonna be stay on the footer of your calculation report. And in the future, you easily will get all the contact info from your side, but you're gonna deliver it to your customer, well presented on that report. Today, the focus was axial connection. So I take it from right side the application. And if I'm looking at the application side here, then today we're looking in a 90-degree connection. And let's say on the beginning, I don't change any parameters, but you could change here the type of timber here, the type of timber also here in a subconstruction area. But what I wanted to bring it up here in the first stage is that when we go directly to the design, then often you will get the explanation mark. And the explanation mark will say that you need to check separately the tension perpendicular area, which means that the wood could split it here. So it's a little bit connected to the Eero's presentation today, what he was showed that the glue lamp, you need to find out the strength of the different layers. So to get also the timber strengthened. The easiest way on this case to get rid of those explanation marks are when we go back and we move the location of connection. So we bring it a little bit lower. So when I now go into the design area, then we see that there is only left 2-3 applications with just short fasteners. When we go for longer fastener, let's hear, then that will be disappeared. And for example, when we look at this connection at the moment, then you could look at also in a cross section that 47% maybe not satisfying me. On security level, you could also use other option with the same length of fastener, where you're gonna have a double amount of fastener because the width of the support beam is able to put here 4 fasteners across the wood level. Now, as today's subject is to talk about thin wood, which is very popular in our Eastern Europe region, and we look in this connection part here could be a 45 millimeter. Then we go back and look at here, where is the dimension area? And let's say the dimension area here, we will change it to 45. You see that turns also here red. So we change here to the 45. We can have that maybe 250. And we like to have that ordinary timber. So we can choose that as well. Let's say the timber is C24, not C16. And now when we go to the calculation, then I don't change any other parameters at the moment, but I put it in a design, and we find out that there is no solutions. So we are not like kind of able to do the calculation because the wood is so thin. But as we know, there is some edge distances. Then we are not able such a thin wood to make this cross connection. So in the first steps, I recommend to change here either one the lineup of the fastener way or making a pre-drilling. So you're able to do also pre-drilling and test it also then. Does it give us a pre-drilled hole better edge distances ables? But as we see, the pre-drilling as well doesn't give us an opportunity to do that. So we are having the only option here that we're gonna do it, let's say, vertical lineup of the fasteners. That is also possible for horizontal lineup for thicker wood. As we see here that there is thin wood case also no option at all. So only option here to go is on vertical parallel fastening point. If they're gonna be in upper level, we're gonna have the similar explanation mark. But we could do it again, move it a little bit lower. And it shows that we need to connect it or install the fastener from up down, but actually we could do it also from down to up. So if we're gonna have it here a wall, then we are able to fix it from the bottom up, the connection, just following the similar instruction where the fastener is coming. And let's say also increase it here a little bit more difficult service class. We could also load up here more higher design values. Let's say put it here 4, not 24, but 4, and we'll see. Do we get some solution, or for that wood application, it's not enough wood for this way to go? At the moment, we didn't found any explanation marks. We found that we have a option for fastener diameter 6.5, 8, and 8.2. And if engineer wanted to even sort the screws, you could click up here the additional window and put it that minimum diameter I wanted to use is, for example, 8. Then you get sorted the table so that you have less fasteners in choice, for example. Also, you can select it here. Do you want to have 1 or 4 fasteners? At the moment, I have to then switch back on a screw level to, let's say, 0. That it gives me a wider range. Then here we could bring, for example, with 6.5 fastener option, where is also 3 fasteners in it. So it brings a third one also in a range, and we could make the calculation. So in a project area, we could fulfill all our project names, info, and let's say we make a sample here, Academy 4, the day, and I put it here times 3 fasteners. And if we will fill that up, then we can go to the report. And when we click the report area, then you will get a nice document to look over. That's the area where you could fill up all the project site. I think I have filled up one project site here before as a sample, for example. It comes like that. Then we can, I will enlarge it a little bit, the picture, for your better view. Then we see all the selected timbers for this application. We see also the loads. we see we did select the service class 2 and put the load 4 kilonewtons on it. Here is the use documents on that area, and that's the document we can deliver for the installation guys. All parameters nicely in, distance is well described, and here is also you can double check all the project calculation details. So this is the result of the day's presentation. If you have more questions, you are welcome to come back to me. I will move that one down at the moment. And coming to the end, maybe here just for info that ESSVE in Eastern Europe have also other services. Contact our local sales organizations, ask for pull-out services and concrete or timber, whatever you need it. Also look from our website. We have a separate calculation program for concrete application. And from my side, thank you very much. Here, before we go to the questions, I will also raise the poll, and will ask you a question about ESSVE calculation program. And you please choose two most common options. What you're gonna use in daily business, and that help us to develop our calculation program more further. At the moment, we have there lateral and axial application, but there is also in the future view looking forward for notch and reinforcement. So you can make your choices here, what you wanted to have it, and give us the feedback. At the moment, I see that it goes roughly so that 7 responses have arrived, and the second or the first biggest selection is either one reinforcement or notch. It's changing the location, and fight also comes lateral, but equally you use all of those from at least at the moment view. And I give a word to DR now. Thank you.
Thank you, Eero, for your great presentation. And we see if we have more questions or if somebody have questions. But I have one question for Eero. You talked about that we can screw from above or from the down, depend on the situation. Is it to be different in the capacity for the screw if we screw from upside or opposite side from downside?
If the question is me or is a question to Eero?
Yeah, it's a question for Eero.
Okay. Yeah, it depends on the situation. If you change the direction, it might be that the screw is either compressed or pulled. So when it's under tension, it doesn't matter. But when it changes also the force acting in the screw to be compression, then it might be that this buckling is decisive and the capacity is a little bit smaller.
But we don't talk about Chris screw. We talk more about parallel screw when we screw from.
Oh no. Then yeah, in that case, it's not it is not different. It's the same.
It's all the same.
Yeah.
It depends on the length of the
Yes.
thread in the
Okay.
in the second or hidden. Thank you. I don't know if we have other questions. The time is running out. 9:30. Do you have more questions?
I have raised one question which repeats a little bit on an earlier presentation. How to ensure the secure connection in a joint where the fixing screw works on the pull-out? I put it that in the chat field.
Yeah, in the pull-out, when we have the case pull out, we can always design the connection like that the pull out itself is not decisive. So the decisive part is steel strength, and when the steel is already involved, then we can ensure some amount of ductility in the connection. So yeah, the designer can regulate that with the length of the screw.
Thank you, Eero. We don't have more questions. Thank you for, you can just answer these questions to that, Eero, how you're satisfied with our presentation today. Please, if you can answer.
Actually, today is more focused how you are satisfied with the ESSVE TimberTech construction product assortment. And we're looking forward that who is using our fasteners, you can give us a feedback also how good, or is there something missing, then it's fine, you put it there lower rate. So we are very looking forward how satisfied you are with ESSVE product assortment at the moment.